Hi, geometry students. Welcome back to Geometry Chapter 1, Foundations of Geometry. We're taking a look at Section 1-3, Measuring and Constructing Angles. Our objectives are name and classify angles and measure angles and angle bisectors. We have a lot of new vocabulary: angle, vertex, interior of an angle, exterior of an angle, measure, degree, acute angle, right angle, obtuse angle, straight angle, congruent angles, and angle bisector. Some of those terms I know are familiar to you and some of them are new, but don't worry, by the end of this lesson, you'll know what all those terms mean. And if you don't, please make a notation in your notes so that we can go over the definitions in class. As always, we're getting started with a warm-up, so I would like for you to turn the video off, work on questions 1 through 4, and then turn the video back on when you're ready to check your answers. See you back in a minute. In number 1, we need to draw two rays, ray AB and ray AC. Notice that they have a common endpoint, endpoint A, and it says where points A, B, and C are non-collinear, meaning they're not on the same line. So we have common endpoint A and rays AB and AC drawn. If you have any questions about that, write your questions down right on your notes so we can discuss in class. In number 2, we want to draw opposite rays. Remember, opposite rays must form a line, DE, ray DE, and ray DF. Notice the common endpoint D, so that's going to be between, that point D is going to be between points E and F. Again, opposite rays, that was a new term we learned in the previous lesson. In number 3 and number 4, both, we need to solve equations for the missing variable x. And I made a notation on number 3 so that you would be able to see the like terms. If you have any questions about any of these, again, make a note in your notes, please, and then let's discuss in class. The warm-up questions kind of primed us for this next little section where it says an angle is a figure formed by two rays with a common endpoint that we call the vertex. And you can see in the diagram that we've got an endpoint R, and we have two rays, ray RS and ray RT. Those two rays, along with their common endpoint, form an angle. And the way that we name the angle, we're going to have a few different choices. You can see that we have that number 1 inside of it, so we could call this angle 1. We also don't have any other angles that conflict that would make it ambiguous, so we can also call this angle R. And then we have the way that we typically refer to angles using the 3 points that create them, which means we would also call this angle R, SRT, or angle TRS. And when we use 3 points to name an angle, then the point in the middle has to be the endpoint. So it's kind of like we're naming the angle using the 3 points, but they have to be in order, picking up your pen and not lifting it back up again. So angle SRT, we could also call it angle TRS. Now, the last part of this section reminds us that we have the interior of an angle, which is between the two rays, and the exterior of the angle, which is a set of all points outside the angle. So we have, again, as I said a minute ago, we have a lot of new vocabulary here that we've learned. And while you may not be tested with specific definitions, you are going to be expected to know what all of that means, all of that terminology, and be able to use it appropriately. And also to know how to use the notation. All right, let's take a look at example 1 on the next page. We cannot name an angle just by its vertex if the point is the vertex of more than one angle. And instead what we do is we name the angle with all 3 points, with the middle point always being the vertex. This is a very common mistake that students make. And what ends up happening is we do have some names of angles that are ambiguous because we have more than one angle that could be called that same angle name. So let's take a look at example 1, naming angles. A surveyor recorded the angles formed by a transit point A and 3 distant points B, C, and D. Name 3 of the angles. So we're going to start out in the example, and notice it's the same set of 4 points 3 different times. So we can create a bunch of different angles here. So on the left, we're going to create a ray AB, another ray AD, knowing that this allowed us to create angle BAD. Remember, that center point has to be the vertex, or we could also call that angle DAB. In the middle set of points, we're also, again, going to create ray AB, but this time we're going to create ray AC also. And the angle that we've created this time can be either known as angle BAC or angle CAB. On the far right hand side, we're going to create ray AD and ray AC, and we know that we've just created angle CAD or angle DAC. Now I'm going to draw that set of points one more time. We have A, B, C, and D, and let's just name them A, B, C, and D. And I want to show you how confusing it can be when we've got all of those rays drawn as to which angle we're talking about if we just talk about angle A. Angle A obviously could be any of the angles that we drew a few minutes ago, but not only those, it can also be a fourth angle, and that would be angle BAD, which is the big angle, if you will. So 4 different angles that we could create if we named any of them angle A, because it would be confusing, it would be ambiguous, we wouldn't know exactly which angle we were talking about. So we're not going to do that if there's any possibility that we could get confused. We're only going to use the single point to name an angle when there's no other possible angle that can be drawn there. Otherwise, we're going to use the 3 points to name any angle. In middle school, you learned all about or possibly before, you learned all about measuring angles in degrees. Degrees are not the only units that you can use to measure angles, and later on, you are going to be learning other ways to measure angles on a circle, or any angles that are even not on a circle. But for right now, we are going to use degrees, and we know that there are 360 degrees in one circle, so 1 degree is 1/360th of a circle. We have something that we call the protractor postulate, and it says, given a line AB and a point O on line AB, all rays that can be drawn from point O can be given a 1-to-1 correspondence with the real numbers from 0 to 180. And that's a very fancy and formal way of saying anytime we have an angle, we can use a protractor to measure it. We just have to line it up with line up one of the rays that make the angle with the line on our protractor. So on our protractor, you can see that we have a line, and we're going to call this line RS. Okay, so that's the line. And point S is located at the center of our protractor, what they refer to in the protractor postulate as point O. So what we notice is there is a ray that has been drawn from point S to point T, or going through point T. And we can measure the angle that's created, angle RST, by lining up our protractor with the vertex of the angle, which we've done at point S. And then the ray SR corresponds to the 0, if you will. And then what we can do, you can see where it starts counting on this outer ring of numbers, and we're going to go all the way until we get to ray ST and then stop. And that outer number, 110, gives us the measure of angle RST. And the notation that we use for that is measure of angle RST, and remember we're measuring in degrees, so we're going to say is 110 degrees. Now you'll notice that there's another angle that has been created, and that's this angle over here. And that one, the 0 starts over on the right-hand side, and we would trace across to that lower number, 70. So that angle would measure 70 degrees. And it's probably no surprise to you that the line is made up of two angles, angle RST, which measures 110, and the other angle, which measures 70. Those two add up to 180 degrees, which forms a line, and that's what we call a straight angle. Anyhow, let's take a look at another protractor example on the next page. So this reads, the measure of an angle is the absolute value of the difference of the real numbers that the rays correspond to, or correspond with, on a protractor. So the measure of angle DOC is equal to the absolute value of D minus C, or the absolute value of C minus D. We know that those are going to both give us the same number. So let's take a look at the measure of angle DOC. Ray OD is hitting the protractor at what looks to me like 65 degrees. And ray OC on that same outer ring of numbers on the protractor looks like it's hitting the protractor at 135 degrees. So when we want to find the measure of the angle between these two rays, angle DOC, we can set it up in this way. The measure of angle DOC is equal to the absolute value of 65 degrees minus 135 degrees, which is going to give us the absolute value of negative 70 degrees, which of course is going to be 70 degrees. If we set it up the other way, we're going to get the same number. Measure of angle DOC can also be thought of as the absolute value of 135 degrees minus 65 degrees, which is still 70 degrees. So that's the measure of this angle, angle DOC. Now imagine we're trying to find the measure of angle BOD. So that ray OB lines up with the 0 line on the outer ring of the protractor, the outer ring of numbers on the protractor. So all we have to do really is start at 0 and count our way up to wherever that ray meets. So that would go from 0 to 65 degrees. So we would say the measure of angle BOD, which is also equal to the measure of angle DOB, is 65 degrees. Over on the right-hand side of this protractor, if we were trying to find the measure of angle AOC, then again, we see this lines up with the 0 on the protractor, but this time on the inner set of numbers. So we would start at the 0 there and go up to where the ray hits the protractor. And in that case, we would say the measure of angle AOC, and you can see that it goes from 0 to 45 on that inner round of numbers, that inner circle of numbers. So we could say that that's 45 degrees. Now, if we wanted to use the outer row of numbers, that's fine. We just have to do it slightly differently, the way that we showed in the original example with the measure of angle DOC. And we would say the measure of angle AOC would be equal to the absolute value of, again, we're on that outside set of numbers, 180 degrees minus 140 degrees, well, 145 degrees, sorry, well, that's where it hits. And that, of course, is going to be equal to the absolute value of 45 degrees, which is 45 degrees. So either way, we're going to get the same answer, whether we use the protractor postulate or we line up with 0 and count either on the outer ring of numbers or on the inner ring of numbers. This is going to make more sense when we're in class together and we are practicing with an actual protractor in your hand. So don't worry, I'm sure you're going to catch on to this very easily. If you have any questions, write them down in your notes, but again, we are going to be practicing with a real protractor in class. When it comes to different types of angles, I know that these terms are familiar to you. An acute angle is an angle that measures more than 0 degrees and less than 90 degrees. So if it measures 0 degrees, there's no angle there. It's just a ray. because there's no distance in here if it measures 0 degrees. All right, if you have a 90-degree angle, we call that a right angle. So if it measures between 0 and 90, we call that acute. If it measures exactly 90, we call that a right angle. And we also say that those two rays meet perpendicularly. You're also familiar with the term obtuse angle, and that is an angle that measures more than 90 degrees but less than 180 degrees, because once we hit 180 degrees, we call that a straight angle, and the straight angle is formed by two opposite rays, which we talked about in our first lesson in this chapter. All right, let's take a look at example 2 where we are measuring and classifying angles. The instructions say find the measures of each angle and then classify each angle. The first one in part A that we want to look at is angle WXV. And I've marked angle WXV in green. So the way that we can look at this is, again, we're lined up, ray XV is lined up with the bottom line that goes across our protractor, which creates the straight angle. And so what we're going to do is we're going to line ourselves up with the 0. That's one way to do it, remember, and not the only way. So if we look at that 0, and then we just count up to where the other ray, hits the protractor. So that ray XW hits the protractor at 30 degrees. So we would be able to say the measure of angle WXV is equal to 30 degrees. Now, if we decided for whatever reason to use the outer ring of numbers, which we can do, once again, it's going to line up with 180 there, and it's going to intersect with what looks like 150 degrees. So in that case, we would say the measure of angle WXV is equal to the absolute value of 150 degrees minus 180 degrees, which is the absolute value of negative 30, which is 30 degrees. So we get the same answer both ways. The second part of the question says classify each angle. So we know that the measure, and I'm paying close attention to notation here because I want you to pay close attention to notation. So the measure of angle WXV measures 30 degrees, it's 30 degrees, and in order for us to classify, we have to go back and look at our definitions, and we know that if we have an angle that measures between 0 degrees and 90 degrees, then we classify that as an acute angle. The next part of the question, part B, says we want to find the measure of angle ZXW, which I've highlighted in blue. And we're going to look at it both ways, both on the outer ring of the protractor and on the inner ring of the protractor. So let's start on the outer ring of the protractor. We can see that ray XW falls right here at 150, and if we scan across to where ray XZ hits the protractor, we see that that's 50. So that means that we're going to be able to write the measure of angle ZXW as the absolute value of the difference between 150 degrees and 50 degrees. So that's going to give us the absolute value of 100 degrees, which is 100 degrees. We said that we would also be able to do this on the inner ring of the protractor, so let's take a look at that. That's going to go from 30 degrees to, let's see, where are we here? 30 degrees to 120 degrees. So the measure of angle ZXW can also be the difference between 30 degrees, or the absolute value of the difference between 130 degrees and 30 degrees. And so that's going to give us also, same thing, 100 degrees. So we've got the measure of the angle, and using the measure of the angle, we need to classify that angle. And we know that when we have an angle that measures between 90 and 180 degrees, we call that an obtuse angle. Another term that we're going to be using all year is the term congruent. We can have congruent angles, congruent segments, congruent triangles. Congruent basically just means that things are the same size. In the case of angles, congruent angles have angles that measure the same measurement in degrees or whatever units we're using to measure. When we have congruent angles, we use a specific notation on the picture that we call arc marks. And you can see that these are the little curved marks that I'm highlighting, that basically that's one way that we can say that these two angles, angle ABC and angle DEF, are congruent with each other. Now let's say in addition to those two, we have some more angles floating around on the same diagram, such as angles XYZ and PRQ. If these are also congruent to each other and on the same diagram as congruent angles ABC and DEF, then what we would do is we would put arc marks on these two, but we'd put a double set of arc marks to show these two are congruent to each other. The other ones are congruent to each other, but they're not all congruent together. We have something similar that we use for segments, but they're tick marks. So if we have a pair of segments, segment GH and segment IJ, that are congruent to each other, then we indicate that congruence, that relationship of having the same side with a tick mark, the same number of tick marks on the two segments. I know that this is something new and it may feel a tiny bit uncomfortable to use this new notation, but don't worry, you will get used to it. We're going to get plenty of practice this year. Let's take a look now at the angle addition postulate. It says if we have a point S on the interior of angle PRQ, and we can see angle S is between ray QP and ray QR, then the measure of angle PQS plus the measure of angle SQR gives us the measure of angle PQR. So this is called the angle addition postulate, and it says that we can add two adjacent angles to the measure of two adjacent angles to get the measure of the larger angle created by those two angles. We're going to use this new angle addition postulate that we've just learned in example 3, and I think you'll find it very straightforward. Example 3 says the measure of angle DEG is 115 degrees. Remember, the measure of angle DEG is the large angle in our diagram. Then it goes on to say the measure of angle DEF is 48 degrees. And we need to find the measure of angle FEG. Now, I know that you can solve this very quickly, but I want you to set it up in the method indicated in the angle addition postulate, because as soon as these problems start getting more complicated, I want you to fall back on the correct way to do it so that you're guaranteed to get the right answer. Remember, now we're finding the measure of angle FEG, but we're going to start out by setting it up like the angle addition postulate. And that means we're going to say that the measure of angle DEF plus the measure of angle FEG added together gives us the measure of angle DEG. And now we're going to substitute in the numbers that we were given. So for the measure of angle DEF, we substitute in 48. We don't know the measure of angle FEG, that's what we're trying to find, but we can plug in 115 degrees for the measure of angle DEG, which is the large one all the way across. Now at this point we know that we can find the measure of angle FEG by subtracting 115 degrees minus 48 degrees. We've turned it into a very simple algebraic problem to solve. And again, when we're using proper notation, we are guaranteed not to lose any points for notation. So we have found the measure of the missing angle that we needed, 67 degrees. Remember to write down any questions in your notes so that we can go over them in class next time we're together. More vocabulary. An angle bisector is a ray that divides an angle into two congruent angles. This means two angles that are exactly the same size. So if ray JK bisects angle LJM, then we have two congruent angles in angle LJK and angle KJM. I just want to show you notation that we have here, which indicates congruence. There's a lot of notation in this statement. When we talk about ray jk, remember j is the endpoint, and the ray goes through point K, and we use the arrow facing to the right. And angle LJM, we're talking about, again, we use that angle symbol. The middle letter is the vertex of the angle. And then, of course, this symbol is congruent to that we're going to be using, again, all year long. So let's take a look at example 4 using this angle bisector definition that we've just learned. We want to find the measure of an angle. We see that ray KM bisects angle JKL. That statement tells us a lot of different pieces of information. Number 1, point M is on the interior of the two rays KJ and KL that have a common endpoint K. Also, the ray that was created, ray KM, created two congruent angles, JKM and MKL. And this is exactly the information that we're going to use to set up the algebraic equation that's going to help us to solve the problem. Let's start, however, by just labeling what we've got here. We have 4x plus 6, the measure of angle JKM, and the measure of angle MKL is 7x minus 12. Now, we're going to start with geometry notation. Angle JKM is congruent to angle MKL. And that means that the measure of angle JKM is equal to the measure of angle MKL. Now we can substitute in the algebraic expressions. For the measure of angle JKM, we're going to put in 4x plus 6, and for the measure of angle MKL, we're going to put in 7x minus 12, and now we're going to solve the way we would any algebraic equation. And we end up with a value for x of 6. However, we go back and look at the question, and we see that we didn't really want x to be our final answer. What we want our final answer to be is the measure of angle JKM. And the measure of angle JKM was 4x plus 6, given to us as 4x plus 6. So now we can substitute in our value of 6 that we found, and we can see, remember that we're finding an angle measure, so the measure of angle JKM is going to be 30 degrees, and that's our final answer. This was a jam-packed lesson, and I know some of it is not going to be entirely clear to you until you actually go through and do the practice problems. So I'll see you in class where you'll be working on your practice problems and math space associated with this lesson.